then we got a tip at one of the forums in one of the emails, and now it gets interesting for you, because I invite you to do this experiment at home or right now. So you can also find the script then in the public repo where you can find all the slides. So just create a loop over a number of cycles, and then within this loop, just spawn processes. And while you're spawning processes, just collect some memory globally. So that's actually just basically the same as we do in SCons, right? So we spawn processes a lot for all these single execution lines, and then we collect build information. So our memory usage grows, and the script just basically simulates that. And you see there's nothing else in there, even the arguments. It's just printing out a command. It's not even actually compiling something. So it should be very fast. And the results you get look something like this. So there's our nonlinear behavior. So it's not the fault actually of Python or SCons. It's really on the lower level. And the actual problem is the fork call that's used within subprocess popen, for example. So just to spawn off a new child, a new process. And why is that? Well, the parent and the child, so you can see them here. So they both use the same address space. And actually you would expect, yeah, well, so there's no overhead related to copying things. But both have an MPT, which stands for memory page table, and this memory page table gets copied. So since the address space is divided up into blocks of 4K each, so the more memory you globally allocate in your parent process, the more time you need for copying this memory page table. And that's the nonlinear behavior we see. So, and that's the basic problem here. Well, what's the way out? We looked around a bit, and you can also find several talks related to performance in Python for the last conferences this year. So I just have a few links here, and they're all very interesting, and just go look at them. But yeah, for this problem, they don't really help that much. So the first link is pretty close. So FFI looks like a valid solution, but as you've seen before, so we use these kind of environments a lot. And with FFI, so foreign function interface, you can't really do this. So this is just not a solution for us, or was not a good solution for us. So we invented our own, and it looks like this. What we have currently is a simple script. It's called subprocess Py and was created by some people at Intel. They are working on an SCons extension called parts. So this is Jason Kenny and his team. And what the script does is it uses C-type. It reaches into the shared library, the libc.so, and grabs out Posix spawn. And with this, it replaces the execute child function in subprocess popen. And the advantage of this is that the fork is out of the way. As you can see here, the Posix spawn will do a vfork, which is much more lightweight than the default fork, and will then execute, will do an execve. And yeah, so with this, we have this memory copying, this memory page table copying out of the way, and we get much faster results.